All right, we're looking at question number 4 of the 2015 JAMB Math exam, and we're asked to find the maximum value of the following expression. Y is equal to 3x squared minus x raised to the power 3. This might look like a simple question, but it actually involves having a significant amount of understanding of differentiation and its applications. Now, there's not enough time for me to go into full theory of differentiation and how you can apply it to solving certain kinds of problems. If you want a full background that will enable you to solve any type of differentiation problem you're going to see on the JAMB exam, you should take the Further Math course that is offered on the jambite.com website. Look in the video description below to find out more information about this. In the meantime, I'm just going to walk you through the approach I would use to solve it, and if again you have questions about the theory, I would advise you to take the course on this. Okay, so we have a function f of x, and we need to find its maximum. Well, the first thing we need to do is find the derivative of f of x, and find the places where that derivative is equal to 0. And these points are going to be either maximums or minimums. So even after finding the derivative of this function, we're only going to have some candidates of points that are interesting to us. We still need to do a little bit more work to find the actual answer. So let's do that first step. F prime of x, which is the derivative of x, is equal to, so in order to find the derivative, what you do is you take the coefficient and you multiply it by the existing constant, and that will give you the new constant of 6. And then you replace the x and its coefficient with x with a coefficient minus 1. So right now we have x raised to the power 2. Instead, we'll replace that with x raised to the power 1. Or you can just write x. We'll do the same thing on the other side. And we get 3 times 1 for the coefficient. And we get x raised to the power 3 minus 1, which is 2, for the new coefficient. So now we know what the derivative of the first function is. In order to find the interesting points, we need to set this equation equal to 0. And so if we did that, we would get 6x minus 3x squared is equal to 0. Therefore, we could say that 3x times 2 minus x is equal to 0. We can further simplify this by dividing both sides by 3, and we're going to find out that x times 2 minus x is equal to 0. And simplifying this, we can tell that x is equal to 0 is one of the possible answers. But also, if x is equal to 2, then we also have another valid answer. So what we have here are what I'm going to call the points of interest. These are the places that could either be both minimums, both maximums, or one could be a minimum and one could be a maximum. And so we don't have enough information just yet to solve this problem, but we know what the possible answers are. So I'm going to save these points, and we're going to come back to it later to try to see if we can solve the problem. As I said before, I'm going to save those points x equals 2 and x equals 0 because these are our points of interest. We want to determine if those points are maximums or minimums, or maybe a combination of both. So let's go ahead and find the second derivative of this equation, and that's going to help us answer this question. So if the first derivative is f prime, then the second derivative is f double prime of x. And we already know the rule, so I'm not going to explain it. That's equal to 6 minus 6x. Now, if we set f double prime of x equal to 0, then we get 6 minus 6x is equal to 0. Now, we want to study this equation at the points of interest. And what I mean by that is, let's see what the value of f double prime of 0 is. And if we plug in 0 for this equation, we end up with f double prime of 0 is equal to 6. because 6 times 0, it crosses out and you end up with 6 minus 0. What about f double prime of 2? Well, f double prime of 2 gives us 6 minus 12, which is equal to minus 6. And so now we have enough information to solve this problem. So based on your knowledge of the applications of differentiation, you should know that if the double derivative of a function is positive, that means you're looking at a minimum. Therefore, when x is equal to 2, that's actually a minimum. And we don't want a minimum, we want a maximum. But if the second differentiation of the function is negative, then we know we are looking at a maximum. And so this is our answer. The answer is whenever x is equal to 2, we're actually looking at a maximum. So that's the answer.